Okay, hello everybody. Today we'll be talking about how the using the particulate nature of matter, and then slowly also try to visualize how are the particles arranged and move within the particles solid, liquid, and gas state. Okay, so we can see that there's three main states that we have studied so far. They are your solid state, your liquid state, and the gaseous state. So these three states of matter, right, how are they intertwined is mainly by two main factors, your melting point and your boiling point, in which the lower the melting point, it will result in a solid state. The higher the melting point, it will become a liquid state. Likewise, the lower the temperature of the substance, if it's below the boiling point, it will become a liquid, and if the temperature of the substance is above the boiling point, it will be a gas. So what we can see is that there are a few main factors of how we can further fine-tune the different particulate model. Number one, the space. The arrangement is number two, how the particles move, and finally, the forces of attraction. Now, these forces of attraction, what do we mean by forces of attraction? It means the forces of attraction between the particles. So imagine this scenario whereby someone is grabbing hold onto your hand. The tighter the grip the person has on your hand, the harder for you to move around, the more restricted you are in terms of movement. However, if the grip on you is actually a lot lighter, lesser, what will happen is it's more free for you to break free and able to move around freely. So same concept with the particles in the states of matter, in which the particles, the amount of force, interaction force that it has in between the particles that they have will help to detect whether is it able to move freely, whether is it able to move fast, is there any, and of course contributing to other kinds of factors. So let's look at the space between the particles first. In a solid state, the particles are very close together. Okay, what we meant by how close is close, they are actually arranged side by side with each other, as we can see. And all these fixed, as they are arranged side by side with each other, you would see that they are arranged in a very fixed and regular pattern. Okay, fixed meaning that the particles do not actually move from this highlighted green color area to other areas. That same particles will stay there consistently throughout the whole state of matter. Secondly, how is it having a very regular pattern because it's fixed already. And they are actually arranged side by side with each other in a very regular and manner, in the sense that it's like one straight row, one straight column. Okay, and hence with the additional being closer together, right? In a way, you have greater forces of attraction because you're holding each other very sharp, close to each other and very strong. And therefore, this will also mean that the particles cannot move freely and they are only able to vibrate about their fixed position. Now, this is very different from if you just say vibrate in their position. It has to be fixed because the particles are always staying stationary and only like moving around within its space, but it's still situated. It's just like the same scenario whereby you are in sitting on your chair and in a classroom and you're only moving your arms and legs, but you're still seated on the chair in that same position. So you are still vibrating, you're in a way like vibrating in a fixed position, as compared to you taking your chair and then you roll it around the classroom. So that is different. That's no longer vibrating already. That's already considered as movement. Next, we look at the liquid. The particles are closer together, but not as close as compared to in a solid. Okay, so in this sense, right, the particles are also, because they are not very close together, they are actually a little bit more spaces. These particles, they are not arranged in a fixed regular pattern. Okay, so what actually happens is they are arranged in an irregular pattern. And over time, the attractive forces between them are actually moderate. So they have actually some, okay, let me write the statement below. They have moderate forces of attraction. Okay, in which the particles will then they have space. That's one. They are also not bounded tightly to among each other, and hence they are able to constantly move over short distance and more importantly slide across each other. They do not drastically move everywhere. Okay, they will just move by like passing through side by side and brushing against each other. So that's what they meant. So in other words, the distance is actually quite close. Now, if we look at for gases, the particles are very far apart. Okay, and in a sense, they occupy all the space of the container. In other words, right, they are moving everywhere. But more importantly, is they are generally far apart from each other. The particles are very. This means that the attractive force is actually very weak. Very weak forces of attraction, intermolecular forces of attraction. Okay, and in this case, right, because you all have no tight bonds towards each other, you have so much space, you tend to move very freely, and so you are able to. So we talk about motion. You will tend to move freely in all direction at high speed. And let's not forget random. Move randomly as well. Okay, move randomly freely in all directions. So this will give you a general summary of the different states of matter and relating it to the particular theory of matter. So what we have studied a little bit in primary school so far is that solids have a definite shape and a definite volume. What is meant by definite means another word for it is called fixed. Fixed means cannot change, unchanged. That means if you take a solid like a ice cube, right, you throw it in any environment, you throw it in a beaker, right, it will still be the cube shape or whatever shape it is. It will not change the shape. Same thing for volume, it will not change the volume. And because of these two, they also cannot be compressed due to the lack of space. To lack of space. Okay, and of course, they don't flow. If we look at liquid, they have no definite shape. What is meant by no definite shape for liquid? It is able to take the shape of the beaker or the container it resides. Okay, and this is mainly due to the amount of spaces available for it to move around and also the forces of attraction between the particles. Because they are not holding, the particles are not heavily attracted to each other, so they tend to be able to break freely a little bit and be able to take the shape of the container. Okay, it cannot be compressed because, as I say, the spaces, even though there is spaces, but it's very negligible. And due to this negligible or lack of spaces, it cannot be compressed. It is able to flow and take the shape of the container, and of course, it has a definite shape, which means the volume do not actually. Yeah, sorry, it has a definite volume because the volume cannot change. For gas, on the other hand, they have no definite shape, no definite volume, meaning it can take the shape of anything. The volume is also interchangeable. Okay, and then it can be flowed, it can be compressed. Now, when we talk about the volume is actually quite relatable to it can be compressed. It's again because it has more it has more spaces in between the particles. And this allows the particles to flow and spread in all directions to fill up the container. So what is then the explanation? So having a definite shape and cannot flow, right? The pebbles, right, are only able to vibrate about its fixed position. Okay, so in other words, whenever we want to explain a particular physical property, we tend to look at four main parts. Number one, the motion of the particles. Number two, the attractive forces between the particle. Number three, the arrangement of the particle. And number four, the distance, or what we call the space between the particle. So in exam, right, it is very good if you are able within your 2 marks, right? Or you are able to explain all these points with respect to the questions being asked. And this will actually ensure that you tend to score better, like you give a better answer. So in this case, right, like let's say definite shape and cannot flow is that the particles cannot move freely and can only vibrate about its fixed position. So using this, you have already answered motion, you have already answered arrangement. But what is the how to enhance your answer? Okay, so it cannot move freely and vibrate about its fixed position because the attractive force is between particles is high or strong. Okay, and the distance between them, in this case is low, but in this case you don't really need the distance part. Okay, next is the particles are packed closely. Now we are talking about volume and cannot be compressed. The particles are packed closely and held in fixed position. So this is where you address the distance part, and then they cannot move any closer together when squeezed. So this is again the motion part. You can add in the attractive forces of attraction again. And of course, packed closely together means having a regular and fixed arrangement. So you again answer number 3.3. So in this case, you got 1, 2, and 3, 4. Okay. So why do they have so in a sense for solid, why do they have fixed volume? Is because the particles are not fixed to move randomly in all directions. Okay, and that for a fixed shape is that the particles are arranged in a fixed and regular position. So these answers may not be the best view way. Always try to relate back to the keywords that has been used over here on this slide. Okay, so later on I'll be trying to if I have time I will write it the more some of the I think all these keywords are already there. You may want to use these keywords to help to embed in your answer. Next for liquid, no definite shape and can flow is because the particles in water they are not in fixed position. Okay, and you saying that it's not fixed is not enough. You have to say what is its actual position. The water, the liquid has a irregular and random arrangement and can slide over each other in terms of the movement. For definite volume cannot be compressed is because they are packed closely together in an irregular and random arrangement and not as close to that of solids. Okay, and not only that, they also have negligible spaces that do not actually allow compressibility. Next, for gas is that the particles are very far apart and move freely and randomly in all directions. In gas, please make sure you have these two words. If you don't write randomly, you just say freely, you won't get the full mark. You have to say random and freely in all directions at high speed. Okay, at high speed. To actually fully describe the motion of the gas. Okay, no definite volume and can be compressed. The particles in a gas are far apart with lots of energy, empty spaces in between, and when squeezed, they can actually move closer together. So that is another examples of how you can go about um, discussing or explaining in terms of exam if they ask you what's this property, what's the explanation. So if I were you, I will try to remember the explanation for these 3 slides. Okay, and how to guide your answer, you can use these 4 main points. Okay, these 4 main points helps to guide or frame your answer to get the maximum amount of marks. Of course, you need to use the correct keywords. Next, we look at how to explain expansion and contraction. Now, a very common mistake that everyone thought is that the particles are from this size, right? They tend to enlarge, become bigger. That is not expansion. Neither is contraction where the one particles become smaller in size. Okay, that is again not what is happening in the particles. Instead, what is happening, right, is that during expansion, the particles will tend to vibrate even greater and they tend to move further and further apart. That means the space, right, increases. And that's why it gives you the visualization that the matter actually becomes bigger. It's not the size of the particle that grows bigger, it's the space that increases. And likewise, when you contract, when you cool, the spaces decrease. Wow. Another thing that actually helps this is that when you cool it, right, the energy, the kinetic energy is lost. And hence it will actually move slower. So lower temperature will result in lower kinetic energy, which result in lower movement. Having lower movement, the volume decreases. They come closer together. Okay, lower movement, lower space distance decrease, therefore volume decrease. And of course, when you heat, by heating, when you increase the temperature, you are actually increasing the kinetic energy. And when you increase the kinetic energy, the movement of the particles will increase. And when the movement of the particles increase, the particles will move further and further apart from one another, having the space to be higher, and hence the volume would increase. So hopefully this process will help you to understand better how it reached from increase in temperature leading to it expanding. Okay, so this is the kind of answer that the flow of the answer that we are looking out for in your exam. So during expansion and contraction, only the distance between the particles change. This is already highlighted to you just now. And that the size and the mass of the particles do not change. So not only size, but the mass, which is how heavy the amount of matter within the particles, they do not change. So if exam question ever asks you when you heat or when you cool something or during expansion, will the mass change? The answer is no. The mass will not change. The mass will actually remain the same. So this one is very important. The mass remains the same during expansion and contraction. What is changed is the volume. So during expansion, volume increase. During contraction, volume decrease as explained in the previous segment. Okay. So let's look at this question, okay, just to have a better understanding of what we went through. First of all, when a substance expands, what are the two things happening to its particles? Number one, when a substance expands, the volume increase because you see down here they are saying expand. So the volume increase. The second thing is the mass remains unchanged. The energy increase. And what form of energy? The kinetic energy increase. Okay, so these are the two main things. So explain what happens to its mass and volume for expansion. As temperature increase, okay, I'm writing short form in exam right in full. This will actually gain, the particles will gain kinetic energy. And when the particles gain in kinetic energy, they tend to vibrate faster, they tend to move faster, and hence they will overcome the intermolecular forces of attraction. And when they overcome the intermolecular forces of attraction, what is this? This is actually the force of attraction hovering between the particles. When they overcome it, okay, they tend to move further away from one another, resulting in the distance between particles to increase. Okay, and when these spaces are increased in particles, this will result in a increase in the volume of the metal. Okay, for mass, on the other hand, mass remains unchanged. Now, why it remains unchanged is because the particles itself, mass is actually the amount of substance within the particle. So this doesn't change as it doesn't influence any gain or loss in mass. Hence, it will remain unchanged at the end of the reaction. Okay, use the particular model of matter to explain the following. Okay, you may want to pause the video to try out the question. If not, you can just continue. I will tell you the answer. So a liquid is difficult to compress. And why is a liquid difficult to compress? Now, it is difficult to compress because the distance in liquid particles or between liquid particles is small or very little, very small. Okay, therefore, there is limited spaces for the particles to slide past or to occupy these spaces. Hence, the liquid is difficult to compress. Okay. Next B. If we squeeze a solid, its shape and size do not change. Why? Because the solid has a definite shape and has the property of a definite shape. This one you can reflect back in the previous few slides that I went through already. So what actually explains this is that for solids, right, the particles are arranged in a fixed and regular arrangement and are held by strong forces of attraction. Okay, hence, because they are held by because of this, they will not be able to move around and only be able to vibrate about a fixed position, and hence, when you squeeze, the size also do not change. And if we squeeze a balloon, its shapes can change. It's again back to the distance issue. So you can reuse that the distance between particles in gas is large, allowing the gas particles to occupy the empty spaces, allowing it to be compressed. And not just compressed, but to also be able to meet the shape. You can also throw in to say that the particles are far apart. Particles are far apart. So again, it's back to the space, okay? So gas is less dense than the same gas when it is cold. So what happens is dense, you have to talk about density, yeah? So density equals to mass over volume. So what happens is when you, in a cold environment, okay, you do know that as temperature decrease, okay, mass remains unchanged, but volume, what happens to the volume? Volume will decrease, correct or not? They must be able to explain why volume decrease, like just now how we explained. And the reason why volume decrease, as volume decrease, mass remains unchanged. This will eventually lead to density increasing. Hence, similarly, Similarly, you will also can explain that as temperature increase because hot gas, right? Mass unchanged. Mass unchanged, volume increase. Therefore, density decrease. So for hot you'll be in red. So again, mass never change, volume increase, density would decrease because it's a mat. It's more of like a math thing. Okay, you can put in numbers to double check. Okay, so that's that, and hence it is less dense. A liquid can flow and take the shape of its container. This one is talking again back to the spaces. So you must be able to explain the spaces between particles, the spaces and the forces of attraction between particles, and you will get your marks. Okay, so this is generally what you can do. So in which state of matter are the particles closest together? This one, quite simple, solid. Moving the fastest, there will be gas because it has a lot of spaces and is held by very weak forces of attraction. Able to move short distance only. Okay, because the thing, okay, it's a bit tricky here. They say move short distance only. They never say cannot move at all. So if it say able to vibrate about its fixed position, that will be solid. But in this case, able to move short distance only, I would say liquid is the best answer. Okay, yeah. So we will stop here for this particular segment, and in the next segment, we will actually be talking more towards of using to describe how the particles actually change move when there's a change in state. And yeah, and that's all for today. Thank you. Please remember to like my video, subscribe to my channel, and click the notification button for more notification when the new video is up. Thank you.